Welcome to MRL. In this learning session, we'll learn the solutions of the examples of Figure It Out, page number 94 of Ganita Prakash, 8th grade CBSE textbook. In that, the first example is, we are given a rectangle and we have to find out all the angles. We have been given one angle, that is angle BAC, as 30 degrees. Now if BAC is 30 degrees, angle 1 also will be 30 degrees, because in a rectangle the diagonals bisect each other. OA is equal to OB, the angles opposite to equal sides are equal, therefore angle 1 is also equal to 30 degrees. And that means in the triangle AOB, if angle A is 30, angle B is 30 plus 30 is 60, therefore angle 9 is 120 degrees. Okay, and now if angle 9 is 120, then angle 10 will be 180 minus 120, that is 60 degrees. If this angle is 60 degrees, then angle 60 degrees plus angle 7 plus angle 4 will be 180, but angle 7 and angle 4 are equal, and therefore we can find out that angle 4 is also 60 and angle 7 is also 60 degrees. So we got angle 7 4 as 60, angle 10 as 120. Now angle 2 is equal to 30 degrees, because DC is parallel to AB, and 30 and angle 30 degrees and 2 are alternate interior angles which are equal, therefore angle 2 is also equal to 30, angle 3 is also equal to 30, angle 8 is equal to 9, and we know that angle 9 we have found out as 120, therefore angle 8 is 120 degrees. And so also we have found out angle 10 as 60 degrees, therefore angle 11 is 60 degrees. If angle 11 is 60, then angle 5 is 60, angle 6 is also 60 degrees. So in all, what we have found out is that angle A is equal to 60 plus 30, 90 degrees, angle B is equal to 60 plus 30, 90 degrees, angle C is 60 and angle 2 is 30, so 60 plus 30 is 90, angle 3 is 30, angle 5 is 60, again 90. Therefore all the four angles of the rectangle, angle A, angle B, angle C, angle D, are equal to 90 degrees, and they are the properties of the angles of a rectangle. Now coming to the next example, there we are again given a rectangle PQRS, and we have been given angle 110 degrees here, that is angle SOR is 110. If angle SOR is 110, then angle 4 plus angle 5 plus 110 is 180, because we know that OR and OS are equal, therefore angle 4 and angle 5 are equal, therefore we get 110 plus 4 plus 5. When we find out, then angle 4 is equal to angle 4 and angle 5 being equal, we get 180 minus 110, that is 180 minus 110 becomes 70 degrees, therefore angle 4 is 35 degrees and angle 5 is also equal to 35 degrees. Now if this is 110, then angle 8 will be 70 degrees. If angle 8 is 70, then angle 70 plus 6 plus 7, which are equal, so we'll get angle 6 and angle 7 as 55 degrees. We have got angle 6 as 55 and angle 7 as 55. So for the same reason, we'll get angle 2 as 30, angle 10 as 55, angle 2 as 35, angle 10 as 55, angle 11 as 55, angle 5 as 35, and when we add all the angles here, we get angle P is equal to 55 plus 35, that is 90, angle Q is 55 plus 35 is 90, angle R is 55 plus 35 is 90, and angle S is 55 plus 35 is 90 degrees, and therefore all the four angles, that is angle P, angle Q and angle R and angle S, are all equal to 90 degrees. That is exactly what I have explained here, and that is true, because in a rectangle all the interior angles are equal to 90 degrees. Here in example number 2, we are given a quadrilateral of equal diagonals of 8 centimeters. The diagonals bisect each other at an angle of 30, 40, 90 and 140, and we have to construct the quadrilateral. Now let us see how to construct them. I have taken 3 examples here. First of all, draw DB, which is equal to 8 centimeters, because we have been given the diagonal as 8 centimeters. Draw DB equal to 8 centimeters. Draw the perpendicular bisector to DB and locate the midpoint of DB, and therefore O is the midpoint of DB, or OD is equal to 4 and OB is equal to 4 centimeters. Now construct an angle of 30 degrees, because we are given the angle as 30 degrees. Construct angle BOC as 30 degrees. Now once you construct angle 30 degrees, you can extend XY. Well, let us take this line as XY and extend it on both the sides. And now what you do is take the O as the midpoint, measure 4 centimeters. Again cut an arc here to locate OC, and again with O as center cut an arc to locate the point A, that is OA is 4. OA is 4, OC is 4. So we have got OB 4, OD 4, OA 4 and OC 4. These two diagonals are 8 centimeters. Now join the ends of the diagonals. We join the ends of the diagonals, that is AB, BC, CD and D are joined. We get a quadrilateral of two diagonals which are given as equal and at an angle of 30 degrees. Okay, that is what is the the construction, and but natural it is 100% a rectangle because the diagonals are bisecting each other, the opposite angles are equal, the opposite sides are equal. Now the second construction, we have to again take 8 centimeters. So let us draw EG as 8 centimeters. Locate, draw the perpendicular bisector to locate the midpoint. Therefore OE is 4 and OG is 4 centimeters. Now what we will do is with OS center cut an arc to measure 4 centimeters and OS center cut an arc to measure 4 centimeters. Therefore we have got what is that EFGH, that is OH is 4 centimeters, and also we have OF as 4 centimeters. Now after having got that, now join the ends of the diagonals, join EF, FG, GH and HE. So we get what we call a quadrilateral in which the diagonals are equal to 8 centimeters, the diagonals bisect each other, and therefore this is we have a rhombus here. We have a rhombus here because the diagonals are equal, the diagonals bisect each other. So therefore we have a rhombus because the diagonals are perpendicular to each other, because the angle is 90 degrees between the two diagonals, therefore it is a rhombus. Now coming to the third construction, again the same as the first one. Draw a diagonal PR equal to 8 centimeters, locate the midpoint at an angle of between the diagonals, that is to angle ROS as 90 degrees, ROS as 140 degrees, and then draw this line segment XY, the line segment XY, and then with OS center mark 4 centimeters to locate S, and with OS center cut an arc to locate the point Q, and we have OS is equal to 4, OQ is equal to 4, OP is equal to 4, OR is equal to 4, and therefore we get, and join the ends of the ends of the diagonals, join PQ, QR, RS and SP, and then we get a rectangle. The procedure of construction of this is the same as the first one, only the difference is here we have taken 30 degrees angle, here we have to take 140 degrees angle. Therefore understand the first one correctly, so it will be very easy for you can construct the second one. Okay, do that. Now coming to the next example, we are given a circle with center O. PL and AM are diameters. So PL and AM are diameters and they are perpendicular to each other. Now we have to find out the type of quadrilateral by construction also, and by we have to justify that. Now let us draw a what we call circle with center O first, then AM is the diameter and PL is another diameter which is perpendicular to it. By measurement we understand that APML is a square, but let us confirm it and by justify it. Now in triangle AOP and MOP, we have OA is equal to OM because the PL is dividing it, is a perpendicular bisect, O is the midpoint. So OA is equal to OM, and angle POA is equal to POM because PL is perpendicular to AM, and also OP is common to both the triangles. Therefore both the triangles AOP and MOP are congruent to each other by SAS congruency criteria, and therefore the corresponding angles and sides are equal. Therefore we have got AP is equal to PM. We have got AP is equal to PM. AP is equal to PM, angle 3 is equal to angle 4, and angle 1 is equal to angle 2, and therefore say for the same, if angle 3 and angle 4 are equal, please understand here, if angle 3 and angle 4 are equal, since the two sides here OP and OA are equal, angle 3 and angle 4 are 45, therefore angle P is 45 degrees, and similarly we can prove that AP is equal to AL, and also the angles are 45 degrees there, and therefore the angle A is also 90 degrees, angle L is 90 degrees, angle M is also 90 degrees. So that is how we can prove it on similar basis, and the similar procedure we follow. Therefore in quadrilateral APML all sides are equal, the diagonals bisect each other, and each of the angles is 90 degrees, and therefore it is 100% a square. Now in the question here we are given two sticks. There is a stick AB and stick CD which are equal, and we are given a thread. Now we have to construct an angle of 90 degrees. So what we do, fix the two sticks, that is stick AB and CD at the center with a screw and rotate the sticks so that the sticks such that the length of the thread BC is equal to the length of the thread CA. So CA and CB must be of equal length, and therefore now if what we have to now understand is that ACB will be equal to 90 degrees. How it is? Now if you take these two triangles here, OB BOC, if you take the triangle BOC and triangle AOC, angle 1 is equal to angle 2, because this is 90 degrees, because we have set the two sticks perpendicular to each other, therefore, and angle 1 is equal to angle 2 because OC and OB are equal, and therefore if this is 90, angle 1 is 45, angle 2 is 45, and for the same reason angle 3 is 45, angle 4 is 45, that means angle C is angle 1 plus angle 3, and that is 90 degrees. So that is what is the easiest way of drawing an angle of 90 degrees. Now a quadrilateral that has opposite sides parallel and equal, a quadrilateral that has opposite sides parallel and equal is 100% a parallelogram. It cannot be the definition of a rectangle. Now on figure page number 107, in figure it out, page 107, we have been given two equilateral triangles. Two equilateral triangles are given of side 4 centimeters each. To join, we have to join the triangles of the triangles. We have to join the triangles to form a quadrilateral and find all the sides and angles of the quadrilateral. Now here I have joined the two triangles, the equilateral triangles at the side 4 centimeters to get a quadrilateral here. Now if you observe here, all the sides are equal to 4 centimeters. Since they are equilateral triangles, angle A is 60, angle C is 60, angle DBA or ABD 60, and also CBD is also 60, CDB is equal to 60, therefore angle B is 120, angle D is 120 degrees, and therefore in this quadrilateral we have got the opposite angles are equal, all sides are equal, and diagonals bisect each other, and therefore it represents a rhombus. Okay, try to understand that. Now the next example is we have to construct a kite. We are given the diagonals as 6 centimeters and 8 centimeters. So let us draw a diagonal BD of 6 centimeters first. Locate the midpoint by drawing the perpendicular bisector, and therefore OD and OB are equal to 3 centimeters each. Now locate a point A on the perpendicular bisector, join AD and AB. From A measure 8 centimeters and locate the point C, join CD and CB, therefore ABCD is the required kite. Okay, with the given measurements. Now coming to the next example, we are given the trapeziums here. We have to find the remaining angles. So now here ABCD is the trapezium, AB is parallel to DC, and here we are given angle as 135 degrees. Okay, 135 degrees here and 45 degrees. So if it is 135 here, if this angle is 135, then this will be 45, because 135 plus 45 is 180, therefore it is 100% 45 degrees is correct, because the sum of the angles at the ends of the non-parallel sides is 180 degrees. If this is 105, this will be 75, because 105 plus 75 is 180, and that is what is the proof, because again for the same reason. Now here in this case we are given angle ADC as 100 degrees. We have to find the other angles. If the ADC is 100, but natural DAB is 80, because 100 plus 80 is 180, because the sum of the angles at the ends of the non-parallel sides is supplementary. And if this is 100, this will this is 80, therefore this is 100, and here also it is 180. For that matter, this particular trapezium is an isosceles trapezium. Base angles are equal. Try to understand that. Now coming to the next example, we are to draw a Venn diagram showing the set of parallelograms, kites and rhombuses, rectangles and squares, and answer the questions. So I have a bigger oval here of parallelogram, a smaller oval here of rectangle, and the rectangle oval intersects with the oval for the kite set. And if you take the kite set and the parallelogram set, we get a rhombus here, and also we get a square with a kite set and a rectangle set. So let us understand the questions now. A quadrilateral that is both a kite and a parallelogram, it should be both a kite and a parallelogram. 100% it is a rhombus, because the set of kites and the set of parallelograms have properties which relate to rhombus, and therefore a quadrilateral that is both a kite and a parallelogram is a rhombus. A quadrilateral cannot be both a kite and a rectangle. Definitely not. A quadrilateral cannot be both a kite as well as a rectangle. It cannot be both. Now every kite is not a rhombus. Definitely a rhombus is every kite is not a rhombus, but every rhombus can be a kite, and that is a very important property which you want to understand from the Venn diagram itself. So these were a few examples of the learning the question, the solving the questions of different examples on the pages from 87 to 109 of the quadrilaterals of Ganita Prakash textbook, 8th grade. Now further we'll be proceeding with the remaining examples in our next video. Okay, note them and keep them for your reference. Thank you.